Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. In today's lecture, we'll be discussing one more topic related to distributions, which is Cauchy distribution, and is one of the important topics in our subject. And before starting that, I would like you all to start revising your subject very well because the exam is not far away from us. And I hope that all of your syllabus has been completed, and this is just a revision class for all of you. And with me, you can solve the questions. And after completing this concept, after completing this class, you can solve the questions on the same concept so that your revision would be brushed up again, and this time we'll be able to clear our exam for 2026. So let us begin with today's topic, which is Cauchy distribution. Cauchy distribution. Now, Cauchy distribution is a continuous random variable distribution. If I say that there is a random variable x which follows Cauchy distribution with parameters lambda and mu, then if I have to state its PDF, which is fx, it will be nothing but 1 upon pi lambda square plus x minus mu whole square, and where x lies between minus infinity to infinity and excuse, excuse me, lambda and mu are always greater than, lambda is always greater than 0. This PDF of the distribution of a random variable is known as the PDF of Cauchy distribution. And Cauchy distribution is a continuous random variable distribution. Now we'll be discussing some of its property, and there is one more thing like we did for normal distribution, standard normal distribution. There is also one distribution which is known as standard Cauchy distribution. We'll be discussing after discussing its properties. So properties of Cauchy distribution will be, first of all, since Cauchy distribution is symmetric, just like normal distribution, Cauchy distribution is symmetric at x equals to mu, which means that if we draw a graph like this, if this is Cauchy distribution, then if this is mu, then it is symmetric on both sides of mu. Then we say that mean is equals to mode is equals to median of Cauchy distribution. All are same and all are equal to nothing but mu. Just like the normal distribution, all its mean, median and mode are equal. Now the second property is of standard Cauchy distribution. If we talk about standard Cauchy distribution, in the Cauchy distribution we put lambda is equals to 1 and mu is equals to 0. If we put this, then our distribution reduces to fx, then our PDF reduces to 1 upon pi 1 plus x square, where x lies between minus infinity to infinity. And here we say that x follows Cauchy distribution with variables 1 and 0, because it is variables lambda and mu, where lambda we had taken 1 and mu we had taken 0. Now here the property, we'll be discussing the properties of this standard Cauchy distribution. Properties of Cauchy distribution with variables 1 and 0. So first one is the same property, mean is equals to median is equals to mod is equals to 0, because mu we have taken 0, so it will all will be equal to 0. No raw moments exist. There is no raw moment that exists in Cauchy distribution. The characteristic function of Cauchy distribution is given by phi xt is equals to exponential minus modulus t. This is the characteristic function. And one more thing, that if x follows Cauchy distribution, standard Cauchy distribution, then x bar also follows standard Cauchy distribution. And then we can also say that xi, x bar or follows n x1 distribution, or is equals to n x1, because x bar is equals to 1 upon n summation xi, I goes from 1 to n, and it follows Cauchy distribution, so x bar will follow. If it follows, suppose y, then x bar will follow ny. That's what we have written here. X1 is the if we talk about order statistics, it is of that. We'll be discussing about order statistics later on. You just need to know that this is also the case in Cauchy distribution. Now there are some properties also of Cauchy distribution, but we'll be discussing them along with the questions that I have for you today. So let us start discussing the question. In the first question, they have given us that x is a random variable which follows Cauchy distribution with parameters 3 and minus 2. What is the probability density function of variate x? So they have asked us probability density function, PDF of x. Now we know that PDF of x is nothing but 1 upon pi lambda plus 1 plus x minus mu whole square. This is our PDF. As we all know, lambda square is also there. Yes. Okay. So this is our PDF where minus infinity x to infinity. Now we just have to put the variables. This is lambda and this is mu. So it will be 1 upon pi. Lambda square is nothing but 9 plus x minus plus 2 whole square. Now if we divide all of these by 9, then it will be 1 upon 9 pi into 1 plus x plus 2 upon 3 whole square. There is one thing that we forgot in the distribution, that it is lambda in the numerator also. So here it will be lambda also. So it will be 3 instead of 1. When 3 get cancelled, it will be 1 upon 3 pi 1 plus x plus 2 upon 3 whole square. So here our option number C matches with 2, where it is 1 upon 3 pi 1 plus x plus 2 upon 3 whole square. This is our correct option. Okay. Now moving forward to another question of today, which is again based on one of the rules of Cauchy distribution. So here the Cauchy distribution states that if x follows, let write it here. If x follows normal distribution, standard normal distribution, and y also follows standard normal distribution, then x upon y will always follow Cauchy distribution, and x upon y will always follow modulus of x upon y will also follow Cauchy standard Cauchy distribution, and whole modulus of x upon y will also follow Cauchy, standard Cauchy distribution. These are the some of the rules that will be required here. So they have given us that u is equals to x upon y has Cauchy distribution, and z is equals to modulus x upon y has the PDF. This has the PDF fz equal to. So we have to find the PDF of this z. Now we know that since u follow Cauchy distribution, so x upon y will be Cauchy distribution of standard Cauchy distribution. So f u will be nothing but 1 upon pi 1 plus u square. Okay, it will be this, but this is where this is for when u is lies between minus infinity to infinity. But when we are talking about z, they have taken the modulus of this. Modulus of this means z is equals to nothing but modulus of u. If we take modulus, that means we are only taking the positive values. So here the value of z will lie between 0 and infinity. But we know the according to the property of this Cauchy distribution, that Cauchy distribution is symmetric about mu. It is equal about mu. So here also it is equal, and here also it is equal. So this becomes 2 times. If we take the modulus, then from 0 to infinity it will become 2 times. So PDF of z, which is PDF of modulus of mu, will be equal to 2 times of PDF of mu, which will be 2 upon pi 1 plus z square. Here we are taking z because we have to calculate the PDF of z. You can also take u, whatever. The options has given our suggestions of only z, so we will take z. I hope that this concept is clear. Since both the sides of mu, the distribution is symmetric. So when we are taking modulus, we'll be considering only the positive side, but we have to take all of the ranges. So we will add the previous side with this side. Both of them will be added, and it will become 2. So our option number C will be our correct option. 2 upon pi 1 plus z square. This was the conceptual based question, no calculation required, just you have to know the properties of symmetric and Cauchy distribution, that x and whenever there is x and y are having standard Cauchy distribution, then modulus of x and y also follows standard Cauchy distribution, but they the range is always 0, z is greater than 0 to infinity. Okay, now moving forward to another question. Here, this is a statement based question which states that, which have two statements. Let us see the first statement. They have said that consider if x follows normal distribution, standard normal distribution, and y also follows standard normal distribution, then x upon y, then the variate x upon y and x upon modulus of y. Here also one more condition will be there, x upon modulus of y. Modulus of x upon y, x upon modulus of y will also follow standard Cauchy distribution. These four conditions are there. So have the same standard Cauchy distribution. Yes, both of them will follow Cauchy distribution, which has parameters 1 and 0 and is known as standard Cauchy distribution. So our first statement will be correct, which is we'll write true. Then about the second statement. If we talk about the second statement, then x denotes the tangent of angle theta. So x is nothing but tan of theta, chosen at random from minus infinity. So this follows uniform distribution from minus pi by 2 to pi by 2. Then x has Cauchy distribution. Now we have to prove that x has Cauchy distribution in here. So to prove this, To prove this, first of all, we have to find the f of theta, which is nothing here. Theta follows. This is theta follows uniform distribution. So f of theta means, the PDF of theta means 1 upon b minus a. B is pi by 2 minus pi by 2, which will be equal to 1 upon pi by 2 plus pi by 2, which will be 1 upon pi. So this is our theta. Now we have to calculate the distribution function of x. So let us calculate the distribution function of x. If we have to calculate the distribution function of x, then let us denote it by gx, and it is given us as probability that x is less than equal to small x, and x is nothing but tan theta. So probability tan theta is less than small x, less than equal to small x. Now we will take the integration of this. Integration for tan theta is less than equal to the small x means, we can also write it as probability that theta is less than equal to tan inverse x, right? So probability theta is less than equal to tan inverse x. So theta is the tan inverse x is the highest value, and minus infinity is the lowest value. But here our range is from minus pi by 2 to pi by 2. So instead of taking minus infinity, we will be taking minus pi by 2. And fx is nothing but 1 upon pi dx. On solving it, we will be getting our final answer as 1 upon pi tan inverse x plus pi by 2 in the bracket. This will be our answer. Now we will differentiate this with respect to x, because this was our distribution function of x. We have to calculate the PDF of x. So for PDF of x, we have to differentiate this with respect to x. So it will be nothing but equal to 1 upon pi tan inverse x with respect to x will be 1 plus x, 1 upon 1 plus x square, and pi by 2 will be 0. So this will be our PDF of x. Okay. And here, if we see clearly this PDF is nothing but of standard Cauchy distribution, and hence the statement x has the Cauchy distribution is the correct. So statement 2 is also correct, and hence we can write it as true. So option number B, which is both 1 and 2 are correct, is the correct option for this question. This second part is very important. You can directly run the result. I have told you how the result came. When x is given as the tangent of any angle theta chosen random from this. So here x is tan theta and theta follows uniform distribution. This is the only thing that you should know, and how to find the PDF. Then only you will be able to answer this question. Now moving forward to another question. Here they have given x and y are standard normal variates. Probability that x root 3 is greater than y. Now x also follows standard normal distribution, and y also follows standard normal distribution. Right? They have asked us that we have to calculate probability x root 3 is greater than y. If we put it equal to, we can write this probability as probability x upon y is greater than 1 upon root 3. And now from here we know that if x follows standard normal distribution and y also follows standard normal distribution, then x upon y will always follow standard Cauchy distribution, right? So this follows standard Cauchy distribution. So let us take as let u is equals to x upon y. So this probability becomes probability that u is greater than 1 upon root 3. But the standard Cauchy distribution has the limits as if we are talking about probability of this, it will be integration from minus infinity to from 1 upon root 3 to infinity fx. Fx is 1 upon pi 1 plus x square dx. And whenever we put our options in this 1 upon x square, then final answer we'll be getting is 1 upon 3. You can solve this integration on your own. I'm not solving it. Your final answer would be option number A, which is 1 upon 3. I've told you how did we convert this from x upon y to u, and this is just the integration part. You can solve it on your own. Okay. Now the last question. Here they have given us that x and y are standard normal distribution. Both are independent of each other. Okay. Then the probability density function of z. If we have to find the probability density function of z, then this is modulus of x upon modulus of y. This can also be written as modulus of x upon y. And just now we did one of these kind of question where we are talking about modulus of this distribution, which will be fz will follow standard Cauchy distribution with PDF 1 upon pi 1 plus z square. But since it is modulus, it will be 2 upon pi. Having the limits z lies between 0 and infinity and 0 otherwise. So here the one that matches our answer will be option number D, 2 upon pi 1 plus z square, where z is always greater than 0 and 0 otherwise, which is our option number D. So this was all for today's class. I hope that you got whatever we have done today in the class. And if not, then you can ask us in the comment section or on our WhatsApp channel. Only relevant doubts will be answered. All the best. Thank you.